Hi, this is Miss Vizone, and this is Precalculus Finding Roots of a Polynomial, Lesson 19. There was no 17, 18. I was absent, and so on my computer, 17, 18 were handouts for when I was out. So there is no lesson 17, 18 if you are confused. All right, so we're just going to continue what we were doing on day 16. All right, so let's start with a not so difficult one. Find the roots of p of x. So the first thing we're going to do is look at what are the possible roots. So possible, you take the number that's by itself. If there's a coefficient, you divide by it. So negative 2. What are all the numbers that divide into negative 2? Negative 2 is my key number here. Plus and minus 1, plus and minus 2. That's it. 1 and 2. Those are your factors of 2. So we cannot factor this. If you attempt, it will not work. I can show you that if you'd like. So if we have x cubed plus 4x squared plus 3x minus 2. Let's attempt to, okay, maybe if I zoom out, that might be helpful. There we go. The first thing you should do is check, can it be factored? Because if you can factor, you really don't want to do guess and check. So the first two, the GCF is x squared, and you're left with x squared, x plus 4. The second two, there is no GCF, so it's 1. The parentheses are not the same, so it's not factorable. We don't have a method. I mean, it's factorable, but we have no method to actually factor this, okay? So we have to use synthetic division. We're going to do guess and check. So our problem, we're going to do plus and minus 1, plus and minus 2. So write out your coefficients. 1, 4, 3, negative 2. I like to start with 1 just because, all right? Start with 1, synthetic division. Which one works? 1 times 1 is 1. 5, 1 times 5 is 5. 8, 8, 6. So this did not work because we have a remainder. The whole idea is find something that doesn't have a remainder. Do it again. 1, 4, 3, negative 2, negative 1. 1, negative 1. 3, negative 3, 0, 0, negative 2. All right, so that didn't work. Try again. So we did 1 and 2. Now we're left with 1 and negative 1, now 2. 1, 4, 3, negative 2. Let's try 2 on the outside. 1, 2, 6, 12, 15, 30, 28. I went really fast, I know. Pause the video, look at it. Bring down the 1. 2 times 1 is 2. 4 and 2 is 6. 2 times 6 is 12. 3 and 12 is 15. 2 and 15 is 30. Negative 2 and 30 is 28. Did not work. Hopefully negative 2 worked. Otherwise, I am in trouble. If negative 2 doesn't work, that means I made a mistake. I will not give you one that has no integer answers. 1, negative 2, 2, negative 4, negative 1, 2. Oh, good. 0. It worked. All right, so I am left with, what is the factor? X plus 2. Now, what was the highest degree? Oops, wrong one. X to the third. So if it's x to the third, when you divide, you get x squared. X squared plus 2x minus 1. So p of x equals, what was it again? X plus 2 x squared plus 2x minus 1. And again, we're finding the roots. So one of them is nice. This one's nice. X equals negative 2. Now, what do you do with this is a trinomial. What do you do with that? You try to factor it. Is that factorable? Can we multiply to negative 1 and add to 2? Multiply to negative 1, combine to 2. Does that work? Nope. Does not work. So what do you do if you can't factor? How do you find the roots? Quadratic formula. Quadratic formula. All right. So let's do it here. x squared plus 2x minus 1. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You can memorize the quadratic formula. If my 3-year-old niece can memorize it, you can memorize it. Yes, I taught my 3-year-old niece the quadratic formula. Negative b, 2. B squared minus 4. What's a? A is 1. Negative 1, 1. So we get negative 2 plus or minus the square root of 8 all over 2. So you need to know the square root of 8. Let's look. Square root of 8. 2.828. Negative 2 plus or minus 2.828 all over 2. Break it into two problems. Negative 2 plus 2.828 all over 2. Negative 2 minus 2.828 all over 2. Break it. One's a plus, one's a minus. You can use the calculator. Negative 2 plus 2.828 parentheses. Divide by 2. 0.414. Calculators are fabulous. Second, enter, bring it back up. Instead of adding, we are subtracting. Negative 2.414. Okay. So we get x equals 0.414. X equals negative 2.414. So we have 3 roots, which makes sense because it's an x cubed problem. Now, at the bottom, I said draw a quick sketch. Right? I'm not asking for anything extensive. We will be graphing, but right now I said draw a quick sketch. Okay? So, a quick sketch. Take a piece of paper. Drawing my axes. My roots were negative 2, 1, 2, 3, 1. Nothing intense. I'm not doing anything crazy here, guys. All right, so 0.414 is around here. Negative 2 and negative 2.414. Now, it's an x cubed problem. That's the highest exponent. So what happens with the behavior? As it goes to the right, what's happening? It's going up and it's coming down. There's no weird roots happening. So literally, it's a polynomial. Just come up, come down, come down, come up. That's all I was looking for. That's a sketch. I don't really know my extrema points.